Dr. Barsan is a professor and former chair of the Department of Emergency Medicine at the University of Michigan. He's been involved in stroke clinical trials since 1983. His academic focus is translational research in stroke and neurological emergency. And he was the only emergency medicine investigator in the initial studies evaluating TPA in ischemic stroke. He was part of the team that designed the pivotal NINDS TPA trial, as well as the 9-stroke scale. Since 2006, he has been the principal investigator of the Clinical Coordinating Center for the Neurological Emergency Treatment Trials Network.
Great. So I think I'll just take the microphone. Might be a little bit for remote working.
There it is.
Okay, great. Good. So I'm going to talk a little bit about clinical trial design and that experience, and of course, on the syllabus it said SIREN 2. We don't know who the SIREN Coordinating Center is going to be yet, but if it is us, we're going to use some of the same plans that is what we did with the NETT. But I'll talk a little bit about this. So just an overview of some of the things that NETT has done in the last 10 years. We have participated in 7 large multi-center trials. Some of them have been completed, 4 of them, and that was Rampart, Alias 2, Protect, and ATAC 2, and then Shine, Point, and the ESET trial are currently ongoing. I think one of the things that we have particularly pride ourselves on is efficiency. So in every clinical trial we've done to date, we have met all our enrollment targets, and we completed the trials on time and on budget. One of the trials, Rampart, we actually finished about a year ahead of time, which was really unique and a wonderful thing. Some of the innovations that we've been looking at is putting adaptive designs into the studies. The ESET study was actually developed as part of the adaptive project, and is the first large-scale adaptive design study we've done in the NETT. And we've had integrated trial and data management working with our colleagues at NUSC. We have what we would refer to as an open network, so that you don't have to be part of the NETT to do a study in the NETT, and I think that was a very different mechanism for most of the other networks. And when we first got the NETT, one of the things I did was I met and called with a lot of people who ran large NIH multi-center trial networks to find out how they did business. And I would say that the vast majority of those networks were closed networks, which means that all the studies that were done in the network were developed by members of the network, and if you were from outside the network, you really weren't welcome. We sort of thought that was not a good idea, because we don't have a monopoly on good ideas, and there's plenty of people who aren't in the network who have wonderful ideas. And then over the years, we've also had a number of collaborations with different organizations, federal organizations, as well as non-federal. So our approach to clinical trials, and some of the ones we've done, is to look at large, simple trials. And simple doesn't necessarily mean easy, but it means trying to keep the data collection limited to the important things that you need to measure for that trial to get the primary and secondary outcomes, and trying not to gather, huge, 200-page case report forms or whatever. And a lot of anybody here who's a NETT investigator knows that a lot of times at the NETT meetings, I always said that, we never want to have a case report form for a clinical trial longer than 2 pages, and that's a little bit of an exaggeration, obviously. But the idea is to keep them really limited to the data you need, and don't collect tons and tons of extra data that really aren't necessary, because it makes it a lot harder to do the trials for the investigators. A lot of our trials, I think almost every trial has been FDA regulated. I mentioned earlier adaptive design trials. We've also done some comparative effectiveness trials in the NETT. 3 of the trials that we've done, one of the current ones, are using exception from informed consent. One study was done done solely in the pre-hospital phase, and we have had, I think one of the things that I'm most proud about in the network is that the site PIs that we've had at the different sites in the NETT have really been a wide variety, very multidisciplinary set of site PIs. So we have had site PIs who are trauma surgeons, neurosurgeons, neurologists, neurocritical care specialists, emergency medicine docs, stroke neurologists, and really run the gamut. which is really sort of fun. One of the most fun, I think, things for me at NETT was actually at one of the PROTECT, which was the progesterone traumatic brain injury meeting, where I was talking to one of the investigators that was there, and he was saying, you know, one of the really cool things I like about this meeting is that I'm sitting here listening to different people talk and making comments and whatever, and he said, I really have no idea whether somebody is an emergency physician or a neurologist or a neurosurgeon or what they are. And I thought that's a really beautiful thing in my opinion, because it was everybody was part of the same team. We have several studies that are in the pipeline right now. Boost 3, which is a TBI trial looking at evaluating the effects of using LICOX for managing patients with TBI to see whether that makes a difference in outcome. We've got another adaptive design study called IceCap, which is evaluating what's the appropriate duration of hypothermia and cardiac arrest. Another adaptive design study called Hobbit, which has got reviewed and we just got resubmitted, which is evaluating the use of hyperbaric oxygen in patients with TBI. And then Arctic, which is an adaptive design study looking at hypothermia and spinal cord injury. So when we're talking about clinical design issues in the NETT, I think there's some of the things, and a lot of these things I'm going to say, I know Chris had mentioned in his talk at the very beginning, and a lot of these things have been mentioned along the road, but I'm sort of going to go over some of these because I think it's sort of a good process to go through when you're trying to think about designing a trial. So obviously the right patient's right dose, right endpoint. The right patient, you know, the patient population you get is very critical. They've got to be a population that is actually physiologically capable of responding to whatever treatment you're going to give them. And I think you need to be able, if you can, to identify patients in whom nothing will work, such as patients with massive TBI. And it's not wise to study patients who you have no chance of showing an effect from your agent or from your intervention, and it's better not to study those patients to begin with. And then you don't also want to study patients in whom anything will work. So patients with very minor strokes or minor TBI who are going to do very well no matter what you do is not the group you want in your study. You also have to consider whether or not your study is really an efficacy versus an effectiveness trial. And there's a lot of debate about this. Sometimes, some of the terms, one of the ones I find that's very confusing sometimes are pragmatic trials. And some people by pragmatic trials mean effectiveness, and other people don't. But basically, some of the big differences between efficacy versus effectiveness trials is that the efficacy trials are really typically more well-controlled. You're using the ideal circumstance, the ideal setting, you're selecting as much as you can a homogeneous population, you're using experienced investigators, and you're really trying to enforce standardized care for your patients and standardized care of the intervention you're using, and you try to enforce that. Whereas in effectiveness trials, they're really more real world, the setting is the real world, you're going to be a lot more heterogeneous, and you're using people who usually provide care to the patients and not specialized coordinators or investigators necessarily. And your study intervention is going to be flexible and not really well controlled. So in a hypothermia study, for example, for, let's say, cardiac arrest, in an effectiveness trial, you would include patients in there who maybe people started to use hypothermia, but they never really got through it. The patient couldn't tolerate it. They never reached target temperature. And there might be lots of patients like that in the study, whereas in an efficacy trial looking at that, you might only use patients who actually achieve target temperature for the hypothermia in a study like that. The right dose, this is a question I think is really interesting. You know, how much, how is it given, how soon, how fast, and for how long? And I can't tell you, it would be a good anecdote. We were working with somebody who had a neuroprotective agent, and we were talking to him about designing a trial, and we said, you know, I said, do you know the dose of the study? He said, absolutely, I know the dose of the study. I said, really, you're sure it's that dose? I'm absolutely sure it's that dose. And so then we asked him the question at the end. I said, let me ask you something. Let's say we use this dose and we do this trial, and the trial fails. Are you willing to walk away from your drug and say it's a loser? He said, oh no, I'd use a higher dose. So I said, okay, thank you very much. So I think one has to really look at how sure are you, and you don't have to know what it is. It's okay to say you don't know. But I think some of these things are really important because, you know, if you, TPA is a great example for ischemic stroke. TPA is only effective if given within a certain period of time. And if you're outside of that window, you're going to conclude that that drug is a loser. And what you don't want to do is a study where you go, darn, I should have done this. And so you really have to ask yourself when you're looking at these questions with dose, is that the way I'm designing this study, if this study fails, am I willing to walk away and say my drug doesn't work? And if you're not willing to do that, then you have to really look at how you're designing the trial. So the right dose might be some kind of baseline characteristic. It might be most commonly weight-based. It might be symptom-based. It might be titrated to different endpoints. We're talking about this with one of the TBI studies. And there may be differences in subpopulation dosing. So you have to consider all these things when you're looking at that. One of the key things that you need to look for in any of these trials, we've obviously stressed that here, is the primary outcome. And a right endpoint is just, I can't tell you, that's just probably the most critical decision you'll make in a clinical trial. You have to decide whether it's best for this to be patient-oriented, or is it a surrogate outcome? Are you using a single or composite outcome? Composite outcomes can be valuable, but they can also be very tricky. You look at some studies with myocardial infarction, for example, where the composite endpoint might be mortality, ultimate outcome in terms of ejection fraction and recurrent chest pain. And it's sort of like, if most of the patients in that composite outcome get it because of recurrent chest pain, but they didn't die and they didn't have a bigger infarct, I'm never quite sure how to interpret that. So it's really important to think carefully about those. Your endpoint might be based on a health state, or it might be symptom-based. The Rampart trial, which looked at pre-hospital use of antiepileptics, was definitely a symptom-based outcome, and the primary outcome was the seizure stop. And that was measured by the clinicians. It might be a patient-reported outcome. In some phase 2 studies, you might really be looking at some kind of a test result. So you might have an imaging biomarker, a serum biomarker, or something like that. You really have to give this an incredible amount of thought in terms of how you select that. One of the ones that's really important are surrogate endpoints, and these are primarily, you're never going to use a surrogate endpoint for a phase 3 trial, but for a phase 2 trial, surrogate endpoint sometimes is a better thing to use because it's an outcome that might occur sooner or with greater frequency than the true outcome of interest. But it's really important that whatever surrogate you use actually is predictive of the true clinical endpoint. And so you have to look at the causal pathway and see whether or not the treatment produces a surrogate outcome which will ultimately produce the clinical endpoint. But the surrogate outcome might be much easier to measure and a much cleaner thing than your clinical endpoint. Good endpoints will always be clinically relevant. They'll reflect the overall disease and be information rich. They've got to be responsive. This was one of the things when we first designed the NIH stroke scale. There were some aspects of the NIH stroke scale that really are not very responsive. One of those, they're very valuable for measuring how much deficit you've got at the beginning, but sometimes not very responsive to treatment. And one of those, for example, was gaze. You might see somebody that comes in with a huge left hemispheric infarct and their eyes are, gaze deviated, they can't go past the midline. But typically that's not a permanent thing with a patient. Typically that's the kind of thing that comes back regardless of the treatment. And so looking at things that are responsive, I think are really important. And reliable endpoints that are valid and reproducible. And I think, there was a great talk earlier about some of the, and I know very little or nothing about neuromuscular trials, but that sounds like a real nightmare in terms of some of those endpoints that they use for some of the NeuroNEXT muscular trials. And it seems like the validity and reproducibility of some of those is very questionable and would be really tough. It's got to be an endpoint that's robust to dropouts and missing data, and an endpoint that does not have a biologic effect itself, and be practical, something that you can actually do. And again, thinking about how hard it's going to be for the people carrying out the trial. So for example, doing a full neurocognitive battery for an outcome is really tough. It's a very, very hard outcome to do, and it takes a long, long time, and it takes a lot of effort. It may be an outcome you want, but it's a very tough outcome to do. trial planning. I think this is something that's really important. You need to really carefully evaluate the scientific premise of the question that you're trying to ask, and a formal systematic review of the topic and of the potential treatment can be very helpful. And then I think the most important thing is putting together your trial development group. What you really want to do is you want to get a multidisciplinary group of people involved in that. And I can't stress the importance of that enough, because I think if you tend to get like-minded people in designing a trial, and that you are not going to end up with as good a trial as if you end up getting a multidisciplinary group of people who might be coming at this problem from different angles. You definitely want to include your biostatisticians at the very beginning, the first meeting, not later on, but the first meeting, because I think you've seen in this process just how important that is. And having some disease-specific experts that may not be part of your group. You may not be part of it, but you want to get people who are experts in that. I think more and more people are also looking at using patient advocates or actual survivors of different disorders, and we've experimented with that to a limited extent, but I think this is something that's becoming more important as time goes on. And I think sometimes that input can be very helpful in designing trials. So how many questions will you answer? Each clinical trial is going to take years. They're incredibly expensive, and if you can answer more than one question, that would be great. You can do that using things like factorial designs, where the effects of the research arms might be independent, but the effects are additive when combined. You can use multi-arm, multi-stage trials or adaptive clinical trial designs, where you might adaptively focus on more promising arms as you go along. Some studies may have to be cluster randomized. So for example, if you're looking at an intervention where you're teaching paramedics a certain way of doing CPR, for example, and you're comparing it with a different way of doing CPR, it's going to be very, very difficult to have a group of paramedics to say, oh, I get the randomization scheme, oh, now I'm doing CPR this way, and the next patient they get who needs CPR, they get a different randomization scheme and they're doing it in a different way. And that's not likely going to work in a situation like that. So you're probably going to want to have clusters, so all the paramedics at one community are trained in one way of doing CPR, and another community are trained in a different way, and that might be a more effective way of doing it. You might, in some circumstances, using registry-based clinical trials might be a very wise thing, and something I think was mentioned earlier in the course, where you've got a lot of the necessary trial data that's already being collected as part of the registry, and basically your job is just to add a randomization. Makes it a very cheap trial to do. We had a PCORI grant we worked on looking at processes, stroke outcomes of care, and we were working with the guidelines people, because a lot of the information that you would need to evaluate that was already being gathered by the guidelines. So you were just adding a research process on top of that, but the registry was already gathering all the data that you need for your primary outcomes of your analysis. The multi-arm, multi-stage trial, I won't go into too much detail on this, but you all know from being in this and hearing some of the talks on adaptive designs that you can start by testing a number of different interventions. And in stage 1, you're dropping some in stage 2, dropping more in stage 3, and then you're ending up with a more limited group at the end. Futility, I think, is important. Interim analysis and stopping rules, I think, are a really key thing. I think one of the things that I think is a lack of focus sometimes is that a lot of times we seem to be really, really focused on the efficacy part of it. And I think sometimes you obviously need to be focused on that, but I think focusing on futility and trying to be very efficient in determining when something is futile is very important too. Because you can save yourself a lot of years of effort and millions of dollars by eliminating something as futile early on, rather than sort of chipping away at it little bit by little bit by little bit, and then spending a lot of your time and effort and many, many years going the wrong way. You can use lack of benefit approaches, which is used more often in adaptive clinical trials, considering only data which are being collected, and futility monitoring will make assumptions about future data based on accumulated data. And trials will stop if there's evidence of harm, or more important, if there's absence of sufficient benefit, which is really predefined. We've got a pre-hospital trial that was designed for StrokeNET that's designed in that way. So there's some different interventions that are being used that if any of the arms that reach a certain level of futility will be dropped, and the trial goes forward with the remaining arms as you go along. So it's really, the purpose of the study is not so much to identify the best treatment, it's to eliminate the treatments that aren't good. So that going forward, if you're going to do a phase 3 trial, you'll know which agents to go forward with and not go forward with all 3. The size and duration of the trial is incredibly important. The event rate in your control arm is critical. So the number of events is going to determine power, not the number of patients. And overestimating the event rate will require more patients in a longer trial. So this is a really, really tricky thing. And I think looking at both of these things, both the event rate and the effect size, are critically important in things that when you're designing a trial, whether it's a fixed trial or an adaptive trial, I think these are great things that you should run simulations on to know just how much you're going to be affected if that event rate is a little bit different than what you had thought, and if your effect size is a little bit different. And those can make a really important difference in the way you design the trial. Things to be aware of: lack of equipoise. I mean, we all know that, but it's still something that comes across whenever we're looking at a clinical trial design. You need to pre-specify all your areas of analysis, and I think one of the things you need to look at is that any trial that you do is not a be-all, end-all. There's going to be trials that will follow, and I think even if it's a phase 3 trial, there's going to be phase 4 trials that follow. So I think looking at this as a point in time and what's coming before and what's coming afterwards, I think are really important. You don't want to make assumptions without evidence. You want to look at your areas of uncertainty, and again, eliminating bias or trying to minimize bias as much as you can is really key. So people know, I think, what confirmation and commitment bias is, but basically this is an area that we run into again and again and again, where people can do vigorous and non-objective searching for possible problems with the data that contradict what they think was going to happen, and then they'll go chasing things in that direction. And I think that this is an advantage, too, of getting multiple people involved, getting multidisciplinary groups involved. And I think a lot of times your biostatisticians can be extremely helpful in that, because they're usually coming in with no pre-specified ideas about what they think is right, and the numbers are going to tell the story. So I think that can be very helpful. Final design steps, I talked about simulations, which I think are really important. When you can evaluate a lot of these things doing simulations, again, regardless of what kind of trial you've designed. So what happens if your dropout rate is 15% instead of 10%, which is what you planned? Your standard deviation is 5 instead of 10. Your event rate changes over time. And this is something I think that's really important. We saw this in one of the trials that we did, where not the event rate, but basically the control group, and this is not unexpected in a trial that takes a long time, where you have maybe better overall care in different areas that have nothing to do with your intervention, but the outcomes in the control patients gets better over time. And when you've got a study that's taken a long time, that may very well happen, but if you're not adjusting for that, and you consider that your placebo group has a 30% good outcome rate, and at the end of the study they've got a 40% good outcome rate, that is really going to mess up your statistics, and it could very much change the outcome of the trial. And I think you have to consider the range of uncertainty that you have. If you think the minimally clinically significant difference is 10%, how happy would you be if it was 8 or 9 or whatever? So I think considering all these things ahead of time, thinking about them, making sure the trial is designed. The worst thing is to end up with a trial at the very end and you say, darn, I wish I would have thought of that. So thinking of all these things at the very beginning is extremely helpful. The simulations can help evaluate your statistical power, improve sample size estimation, et cetera, et cetera. I think we've gone into a lot of detail on this. You can vary things like enrollment rate, different parameters, incomplete adherence, and a lot of things that might help you really really kick the tires on your study design to see just how accurate it will be under different conditions. And anticipated regret, and this is one of the things I talked about earlier with the investigator who was sure he had the right dose. And boy, this is a great thought experiment. And if you tell somebody you get the trial done and you've got everything designed, everybody thinks they know what they want to do, and then you say, if this trial fails, what would I have done differently? Or am I willing to walk away from this and say that this doesn't work? And if you're not willing to walk away from it, then you probably didn't design the trial right. So you really ought to you need to go back and look at that anticipated regret and see what you would have done. And I think one of the, a great example of one of these things where nobody did anticipated regret, what we end up doing if you don't do this is you end up doing acronym 1 trial, acronym 2 trial, acronym 3 trial. I'll use the NASCUS trials as an example. How many NASCUS trials were there? 4? They did the NASCUS one, which was a spinal cord injury trial. They said, darn, we got the dose wrong. They did NASCUS 2, and they did NASCUS 3, and they did NASCUS 4. And they could have had NASCUS 1 if they had considered a lot of these areas of uncertainty the first time, and probably had one trial to answer the question. Instead, there were 4. And they spent a heck of a lot of money. So looking at higher, lower dose, earlier treatment, longer treatment, a different patient population, older patients, younger patients, et cetera, should you use a different primary outcome. But I think a lot of these things are just so critical, and I think one of the things you're learning in this course is that the amount of thought and rigor you put in at the very beginning is just huge. And so banging out a clinical trial to get it out there is not good. I've just had the experience, I don't know if any of you have done DOD trials before, but I just was working with one of the investigators at the University of Michigan on a DOD trial, and I think, boy, if that isn't, no offense against any DOD people, if that's a way to get stuff that doesn't work very well. They'll put out something and say, you have 4 weeks to respond. And it's like, really? I don't know that there's no way I could conceive of being able to design a study where you consider all these things in 4 weeks of time. But I think the more time you put into it at the beginning, even if it takes a year, much better to take a year at the beginning of time designing a trial than to spend a lot of time, a lot of money, and and end up with something that failed because you just didn't do it right. So take-home messages. Translational research is a continuum. I think you need to figure that there are multiple stages along the way, and you need to look at the stage you're in, and you're going to say, what can I learn from this stage that will be really beneficial for me going to the next stage? And I think if you're thinking that way, it helps. Trial design, and there's several people have said this, I think Chris said this in the first talk, is that trial design process is a team sport, and it really is a team sport. And I think the more open your team is and getting people with different perspectives, the more successful you're going to be in designing a good trial. I think you have to address and embrace your areas of uncertainty rather than trying to say, oh, I'm not really sure, but I'm going to go ahead anyway. And looking at those, knowing what they are, recognize them, and try to account for those in your trial design if you can. But sometimes you might have too many areas and maybe you can't, but at least you know what they are. You know what those areas are, and you know the areas where you might be vulnerable. The right patient, right dose, right endpoint, I think is critical. And then I think for anybody, regardless of the trial design you're doing, I think with Kurt's study or his talk he gave on simulations, boy, you can learn an incredible amount from simulations, regardless of what kind of trial you're designing. So I think that would be something that would be valuable to consider in any trial that you're involved in. So that's all I have. I'd be happy to answer any questions. Questions, comments? Well, I'm shocked that you don't.
So how do you know your study is ready to go to a network like that, or potentially what you anticipate SIREN would be like?
I don't know that you're necessarily going to know that. Here's what I would suggest that you do is that at a very early stage, not at a late stage, but at a very early stage, to at least the way we like to do business, and I think, I can't speak for StrokeNET, but I think it's probably the same philosophy, coming in early and saying, gosh, I'm thinking of designing a trial to look at this. I think is really helpful. And then we can, go through the process with you and look at sort of what's out there. And we're not going to try to take the process away from you, but I think, we can give you a lot of good advice about how to pursue this and whether this is something that we think will function in the NET. Typically, what we did in the NET is we had something where we would ask people to submit like a protocol summary, very similar to what you submit to NINDS, but submit it to us so that, I'm sorry? Yeah, right. And look at the protocol summary, and then we can look at that, and there's some studies that we may say, well, they really don't fit the scope of what the network is supposed to do, but beyond that, then we can work on some of those other things. But I think the best thing is to talk to somebody early. Great. Yes?
One more?
One more?
So what are the sorts of things that you would look at in the earlier phase trials that would increase your network's enthusiasm for a trial? So the sorts of things that as you're designing an early phase trial, as many of the folks in the room are trying to do, what sort of information ought they be collecting in those trials to motivate the research community to help mobilize to do the larger trial to prove the new treatment works?
Well, it's a little bit hard to obviously you want some really evidence from a well-done phase 2 trial, because the trials that NETT did are primarily phase 3 trials, or almost all phase 3 trials, and I think SIREN probably is going to be doing the same thing. So you're going to be looking at things that are either ready for phase 3, so there's robust information, well done, learned phase trials, phase 2 trials, and something that you feel you can really go to bat for. There's enough preliminary information that says, I think I can design the right phase 3 trial based on the information that was provided in phase 2. Or maybe it might be, you might have to do an adaptation, adaptations, maybe adaptive design, but there's enough information that it's ready to go to phase 3. It's a little bit vague, but I'm not sure how else to describe it. Maybe Robin has a better idea.
Another example would be to do a biomarker study that could be an ancillary study to one of the SIREN types of trials, and then therefore you learn information in the course of the actual study. So you'll keep your eyes open for what the trials will be in SIREN, and we already have some ancillary studies like iSpot for Sean.
Right. Well, those are right. Supplements or ancillary trials, I think, are really important too. But we're going to be focused, on the big clinical question. I think some of the other things that aren't necessarily, this probably isn't what you wanted to hear, but are things that are important from a network perspective too, would be, is it an area that we want to cover that is very underrepresented? So, for example, there are no phase 3 trials that we've done of spinal cord injury, right? Spinal cord injury is a devastating problem. We would really love to have a spinal cord injury study to do in the network. I think the other thing is we're looking at competing trials a lot of times too, and how many things are in the pipeline. And we were lucky enough to have 4 spinal cord injury trials that were submitted. Then it would be a matter of which one looks the best. And so sometimes some of those things come in too. How would you answer that?
Well, so I think the one thing I would say, maybe you can weigh in on whether you'd be interested in this too, is that one of the important things to establish in the earlier phase is that you really have patients out there with this combination of inclusion criteria. Because I think the biggest threat at any phase, be it phase 2 or phase 3, is that you don't enroll the patients in the trial. And that I think knowing well your population, if it took you 10 years to get the 3 patients into your phase 2 study, that's going to be a problem. And if you did the opposite, you got a lot of patients within a very short period of time, and you really knew how many people were coming into your institution versus how many you got, those things can be very helpful. But I'll let Chris also.
I was going to say, I think the feasibility is important, but I also think that a lot of this is what the students have done during the week, but you have to set up your phase 2 so that you get the answers to the questions that you need to do to phase 3. This is soapbox opinion, not supported by fact, but we approach phase 2 in general, this clinical trial, is completely backwards from the way we should. Almost every investigator I work with comes into phase 2 determined that it's going to phase 3, that the treatment works, unless something happens in phase 2 that would prevent that. And that something is usually so extreme that the chances of that happening, if the drug doesn't work, is basically minimal. So the phase 2 is an exercise, often in the situation you guys are in, where you can't do the multi-site, you got to do the single site before everybody will be comfortable doing the multi-site. But from a scientific knowledge, it doesn't give you any more insight into whether the drug works than what you had before. So I think being careful and thinking of what are these unknown questions and making sure that the phase 2 answers them. Because again, like we've said many times in the course, it's much better to fail at phase 2 than to fail at phase 3.
So I made a comment, as an editorial comment for the Institute too. You know, I think a lot of times there's been a little reluctance on the part of the some of the institutes at NIH to fund very large phase 2 trials because it's big and it's expensive and it's not pivotal. And it's sort of like, gosh, you know, wouldn't you rather fund 2 or 3 smaller phase 2 trials that might go to phase 3 trials as opposed to one big phase 2 trial where you'll have a much better idea of whether it's really going to work. So I think that's an area just in general that we don't do very well on. It's to what Chris was saying in terms of the way that the study is designed. But yeah, designing the right phase 2 where we're really not it. But again, feasibility, I'm sorry, well, I should have mentioned, but feasibility obviously is huge. And that can be very difficult. And you know, there are no great ways to determine feasibility of enrollment that I know. Are we running behind?
No.
Okay. Are you going to respond to my
I just
challenge?
wanted to say the first point about feasibility is that it would only be possible to really get NIH funding to just do feasibility, but in the course of the other scientific studies you're doing, you can certainly find out if it's feasible. But I just didn't want people now to think feasibility study would be something easily funded by the institute.
We know that.
No. I mean, but then as you are also gathering important biological data, biomarker data, clinical response data, also knowing that this is how many patients it took to get into this study, that you could get this many patients, that's additional information that helps your case to make the larger.
It definitely does, but it's very difficult information to get. So, you know, one of the things that we just sort of started to roll out in the NET, and we did this with several other trials, was to basically assign different sites randomly. Let's say if we were considering a spinal cord injury trial, is to have people do a real life, you know, hot pursuit thing of spinal cord injury for a limited period of time. And maybe, you know, if you were at Wisconsin, you know, you do it in, you know, January and July. But in January and July, we would run granular data on all the spinal cord injury patients you had, and the other sites were doing it at the same time. So at the end of the day, we actually had granular, real data, not just from ICD-9 codes, but actually from looking at patients who came to the ER, how soon did they get there, and you know, those kind of things that can be very helpful in knowing whether you really have the patient. We went through a process like that when we were debating doing a warfarin related ICH study, and did it with some pretty granular data and decided that it would take us probably 15 years to complete the study because there just weren't enough patients with the condition, and it got us out of something quickly that could have been a quagmire.
Was it one more question?
Yeah, I was just wondering if actually both of you or either of you could connect it up with a budget talk. And so if you're doing a trial with any one of these networks, then does that obviate the need for individual subs with each of the enrolling sites? Because then the prime award just does one big sub to, say, NeuroNEXT, and then NeuroNEXT basically handles the subs with all the enrolling sites. And is that different for the different networks?
I'll let Chris talk about NeuroNEXT. I'll talk about NET first. So the way most of the NET trials work is there's, with the phase 3 trials, is there's actually usually 2 grants that go on. One from the Statistical Data Management Center and one from the Coordinating Center from the NET. It might be from the coordinating center, or it might be from the trial PI. The trial PI is somebody different. I'll use SHINE, which is a study of glucose control in patients with stroke, as an example. So the main grant for SHINE went to Karen Johnston at UVA, who is not part of the NET. And then there was a statistical grant for, that went to MUSC for doing SHINE. And then we are basically, the NET, the Coordinating Center, was a sub of the University of Virginia. And then the NET sites were subs of University of Michigan. And so that, it can be very different depending on the studies. But I think StrokeNET operates very similar to that.
So in NeuroNEXT, there's master trial agreements, contracts that the sites have with the clinical coordinating center at Mass General. And so all the per subject fees come through Mass General through that contract. So the site where the study is run does not negotiate subcontracts with each of the sites that run the network. From the standpoint of someone doing the study, it doesn't affect budgeting. It's more of the operational where the money flows in and out.
That's so that's what StrokeNET does, which doesn't sound like it's necessarily what that does, and that sends the money directly from the PI grant to the site. Is that what you're making?
The money goes to the PI grant, which has a subcontract with Mass General. So the site only flows from the PI grant to Mass General and from Mass General out to the site.
And that's precisely how StrokeNET works. Okay, so yeah, they're all the same.
So a couple of things. There's one thing I have to say. So ancillary studies, if you do one, some of you might, don't skimp on the budget. Right? I hate ancillary studies, not because they're not scientifically important, but because I've never worked on one that didn't require 10 times the effort from the data coordinating center that they said it would at the very beginning of budgeted for. So if you do one, think about all the things you talked about for the study, budgeting, the scientific aspect, just think of it. So there's lots of good reasons to do that, but we've talked about it in NeuroNEXT, and I always shake. So that's just a plate. Your statisticians and data management people will love you, right? Sharon's fine. So I'm going to talk just briefly about NeuroNEXT, mostly the structure. So, which feeds directly off of the talk that you just had, like phase 2, what you need to know to move into phase 3, because NeuroNEXT is a network that is focused on phase 2 trials and biomarker studies, but mostly phase 2 trials. And it's a slightly different network, which was, I think, one of the strengths and one of the big challenges in when it was set up, in that most networks focus on a particular type of disease area or specific disease area, whereas NeuroNEXT is a network that covers the gamut of the neurosciences. So kind of exactly what diseases does NeuroNEXT cover is hard to define, the same way that Steve Korn mentioned, like what falls under the NINDS umbrella. So whatever falls under the NINDS umbrella that's suitable for phase 2 fits to us. So a lot of that, there's discussions at the Institute if somebody has something and whether it's appropriate or not. But we cover a wide range. So the advantage we have in the network compared to the other talks you hear, there are probably many more people in there who have potential studies for NeuroNEXT because we cover the gamut of diseases. So the three things that NeuroNEXT was put together. And so one of the nice things, if you guys are on social media, which most of you are, I'm sure, there's like Time Hop, the little Time Hop or the Facebook Memories thing that pops up. One of the interesting things, last Friday it popped up and it was like the 5-year anniversary of when the NeuroNEXT grant was reviewed. So that's kind of an interesting thing to think about. So we've been a network for 5 years. A lot has happened in 5 years. It seems like yesterday and it seems like 20 years ago. So NeuroNEXT was designed to do really 3 key things: test promising new therapies, increase the efficiency of clinical trials, and respond quickly as new opportunities arise. So that was really kind of the original thinking behind NeuroNEXT when it was put together. The idea is to try to take potential drugs, and some of the focus was if there were junior investigators like yourself, or in like pediatric areas or other areas where it might be complicated to move things through or difficult to do studies, to try to have this infrastructure where you can increase the ability of someone to come in and tap into that. So there are a couple of things that were specific aspects of the infrastructure that I'll talk about in a minute that are increased to really help someone, particularly like in your area. If you have a small phase 2 multi-site, you have to use at least 4 sites to do this. So it's a UL1 mechanism, so the network infrastructure, there's NINDS personnel, James Cordell and Robin Conwit are kind of the main ones involved. There are many other people at NINDS that play different roles. The Clinical Coordinating Center at Mass General, which Merritt leads, most of you heard her talk on Tuesday night about how she got in her career, and then the Data Coordinating Centers at the University of Iowa. And so the way that NeuroNEXT was set up, there were 25 clinical sites. So there were 25 clinical site awards, and you can see the map. So they were chosen, based on their, they went through peer review, but also there was some thought giving when they were chosen to have geographical distributions. You can see it kind of covers, the gamut of the U.S. from the East Coast to the West Coast to the Southeast and so forth. And then there's also a central pharmacy at Rochester that contracts through the CCC. The why to apply to use NeuroNEXT, so it allows access to the NeuroNEXT Clinical Coordinating Center and Data Coordinating Center, the central pharmacy, the lab, the clinical site. So where that would be of interest to many of you is, I know in the meetings I've had with a number of you, kind of the one-on-ones, one of the things that many people at the stage in their career where you're at right now is access to statisticians, right? That can really help design and run clinical trials. So that's part of the infrastructure. Access the infrastructure also at these clinical sites. There are disease experts in different disease areas. So there's probably, senior clinical trialists potentially in your disease area that you can tap into. So some of the same advantages that you have at the course, right? One of the strengths of the course is that you have access to sit down and have a one-on-one discussion with people who have experience in your field that would be maybe difficult to have on a daily basis. So that's one thing. The other things that are big advantages have to do with the clinical sites. The first two are really dealing more with the efficiency, and the last with more of the design. So when NeuroNEXT was set up, this was way more cutting edge 5 years ago than it is now. But NeuroNEXT uses central IRB, and so to be able to respond to the RFA for becoming a NeuroNEXT site, you have to agree to your IRB would cede to the central IRB. So there's a central IRB at Mass General. That's the IRB of record for all of the studies. That's been in place now for a number of our studies, and it's worked really well. And as you guys know, there's really more of a movement towards the field of clinical trials in general towards central IRB. So it's a lot easier to set it up now. To be perfectly honest, when we set this up 5 years ago, if it had just been up to the institutions to volunteer to do the CIRB, it would have never happened. It really took the fact that NINDS said if you want the money, you have to agree to use a central IRB. So there's a number of places they responded. There's a requirement of the RFA. Yes, we will use this. When the grant was awarded, it's like, no, we're not going to use that. Well, you said you would. Oh, we didn't mean that. So there were a lot of conversations early on to make that happen, but it really put this together. It's been a nice kind of framework of how to do this in kind of the NIH setting, and it's actually worked, I think, really well. The other thing that came up when we were talking about the budgeting was master trial agreement. So each of the 25 sites, and then there are other affiliated sites or spokes, depending on what terminology you use, have negotiated a master clinical trial agreement with Mass General when the network was first formed. That covers all trials that would be conducted through the network. So the other advantage of that from an efficiency standpoint is when a new trial is funded through the network, you don't have to negotiate contracts with each of the sites that are participating in the study. So you guys may not have gone through that yet, but if you ever do, where you have to negotiate contracts with say 15 sites, that can slow your recruitment down by 6 months to a year, just going through all the lawyers and all the different institutions and getting the language done. So that means we're ready to go in terms of the contracts. We don't have to do that for the studies. The other thing that has been very important is more from a design aspect. There's availability of experienced trial design staff that can help flesh out the details of the protocol. So we have kind of two groups of statisticians within our coordinating center in the network. There's a group of kind of master's level statisticians that really manage the ongoing studies day to day. But we have a small group of about 5 senior statisticians with clinical trials experience who we can spread around as new projects come in. They can provide advice. Really, the model is very similar to the course, right? Somebody comes in with a brief idea and they have a lot of the same conversations that you guys have had over the course of this week and fleshing out the proposal. So that helps. The goal of the network with the network infrastructure is that by the time you write the grant, and I'll talk about the flow in a minute, the grant should live or die based on its scientific merits, right? You shouldn't have, I said on study section for the clinical trials section within NINDS, there are a number of things that come through. Maybe it's a good scientific idea, but the statistics are not fleshed out, the data management's not there. There's holes in the clinical trials structure of the grant that would cause it to not get funded, regardless of the scientific merit. The idea of the network when things come through there is those are removed, and it really should live or die based on the scientific merit because there's a network that can handle that. You can have help with design, so your statistical section should be, at least at a high level, pretty solid. So, how to come into the network, and what I get to the whole flow, I have to give a caveat. This is what it is as of today. This changes constantly. Ron's cringing. That's right. So, yeah. So you would contact Robin, or if you have another contact in NINDS, they can point you in the right area. So the first thing is to have a conversation with NINDS because there's internal discussions of, does it fit within the portfolio of what they want to do? That's kind of the initial step. So if it passes that step, then it comes into the network. And at that point, there's 2 levels of review. So I want to clarify one thing, where this is very similar to all 3 networks you'll hear about. The networks don't have funding to do trials. Someone comes in for an idea with the network can provide help, but it's still up to the investigator to write a grant, and the grant has to go through peer review before you have the money to actually do the study. So if it comes in initially, it's reviewed by the executive committee within NETT for feasibility, and that's looking at, are there patients here, what's the enthusiasm across the sites, is it done? It's not a scientific review, so it's really more of a bar of, if this were considered scientifically of merit, is it of high enough interest, is there enough subjects in there that it would justify moving forward with network resources? There's also then an NINDS review of their extramural science committee, which is a little more of a scientific review, but that, the budget has to be fleshed out, so they're looking at kind of, I don't know exactly how that works, but what I gather is more like, is the cost versus the risk and benefits the same?
The rigor is really important,
Yeah.
so you want to have the rigor criteria, then definitely need that.
Right. So you have to pass that. That's not a network specific thing. Any grant, like for a trial that's over $500,000 in any year has to go through that group, right, for approval before you can submit it. So that's true in other situations as well. So one other thing to note, if some of you are at sites that are NeuroNEXT sites, right, come in through the site, anyone can come in. If you come in at an institution, your institution is not a NeuroNEXT site, you can still come in with a proposal. One of the things that is a requirement in the RFA is your institution would have to agree, to cede to the central IRB. That would be a requirement of coming in as a protocol PI if you're at a non-NeuroNEXT institution. Site selection is done after funding. If you come in from a non-NeuroNEXT site, your site is automatically included as a site. Site selection, obviously priority is given to the NeuroNEXT sites. If there's a need for sites outside the network, that can be considered. That's also something that comes up in feasibility because it's not really in the network's best interest to do studies where you have to kind of go outside the network to do the studies if you can, if there are other studies that can be managed within the network. So that's the general sense that I have. To tie it in with Bill's thing, so we've done a number of different studies. I think one of the things I've appreciated more in the 5 years is just how difficult it is to do phase 2 proof of concept studies because they're just fundamentally structured different from phase 3 studies. The network, obviously I'm biased, so take this for what it's worth, but it's been pretty successful. We've had nearly 150 proposals at least come in for that initial review. That's over 5 years. That's a lot. We've done, I forget the exact number, but it's over 35 grant submissions, through 5 years. So if you average that over 5 years, roughly 3 cycles, that's about 2 to 3 per cycle. So a lot of grant submissions. And we've got now, the first study, we've done closeout in the process of writing that up. We've got another 2 that have completed enrollment. We're in the process of following up the subjects for additional time. A 4th that is probably about halfway to 2/3 through recruitment. A 5th that just started, 2 more we're in the process of starting, and then 2 or 3 more that will be reviewed soon. So the original goal was to do 5 to 7 studies, in the 7-year period the network was funded, and we've done that. So, if anything, the harder part has been to not necessarily try to pull more things in, it's try to manage, the interest in the network, and also across the range. I mentioned the study, so we've got spinal muscular atrophy, multiple sclerosis, myasthenia gravis, stroke, Huntington's disease, glioblastoma, Fragile X, right? That's a pretty broad range of diseases in neurosciences, which is interesting because we're working in different areas, but it can be a bit of a challenge. The other thing that I think we've done that I didn't have in here that I will mention, there's references to the common data elements. I mean, one of the things that we've done working with different disease areas is we've probably, become, I wouldn't say experts, but semi-experts in common data elements across different diseases. And one of the things that we've been able to do in working with Joanne Odenberger, who's on I think, leave now, but working with her was pointing out some things like across disease areas, right, that might be inconsistent, because until you use them in different disease areas, you're not thinking of the same way. And so, I think we've been able to do that, and the common data elements, I think, have really helped that process. And I was skeptical at first of the common data elements. I'm now a much bigger fan, and I think that as we've used them more, I think it helps. It helps with the design process, and it's something to be familiar with as you're working in your area. Like, what are the common data elements? How would you use them in a study? So that's NeuroNEXT. Maybe I'll
Is multi-site or being a multi-site a requirement to apply to you guys?
Yes, so part of the feasibility research, so it has to be, so a single site study would not be appropriate, a study with very small numbers. So we had discussions early on, and we said in the, it's on the, so there's NeuroNEXT website that I think, a reference to somewhere there. If you go there, so you have to have at least 4 sites, which is still relatively small study, but that's part. So a single site study wouldn't be appropriate for the network.
That now dovetails really nicely with the summaries you've gotten about NETT and NeuroNEXT. Just my disclosures. And I'm just going to talk briefly about some of the ongoing trials very briefly. So as you heard, the NETT was set up. It was set up in 2006 for phase 3 trials in emergency neurology, or I should say emergency neurosciences. And then NeuroNEXT was is pilot trials in the neurosciences. Well, that came along in 2011, and then in 2013, the newest kid on the block was StrokeNET, and that was set up to pull future stroke proposals all into this one network, and it's all phases of stroke: treatment, prevention, and recovery. And then Robin may touch on this, but my understanding is NETT is ending now, and you've heard a little said about SIREN, and that's going to be all phases of emergency neurology except stroke, but then they're also throwing in cardiovascular, respiratory, and trauma, as I understand it. So those applications are under review, which is why we don't have a presentation on that yet. So StrokeNET is structured just like you've heard with these other places. There's a national coordinating center, there's a national data management center, and then there are regional centers. So Cincinnati is the home of the national coordinating center led by Joe Broderick. And we have 3, I put co-PIs in quotes because it's not technically an NINDS term, but that's what Joe likes to call us. So I'm the acute person, and we've got Mark Chimowitz for prevention, we've got Steve Kramer for recovery. And then our National Data Management Center is at NUSC, led by Yuko and Lynn Lee, and many of the wonderful statisticians that you've gotten to work with here at this workshop. And then we have 25 regional coordinating centers, and so each of those centers applied for grants, and then they had affiliated clinical performance sites, and it's actually turned really huge. So we have 316 clinical performance sites that all have master trial agreements, and all conform to that, so that we're all set to go that way. We also are using a central IRB, just like NeuroNEXT was, or is. And then this shows you the map of roughly where these sites are, these regional coordinating centers. So we have working groups set up for our infrastructure, and this becomes relevant for new proposals, so I just kind of flash this up. I know you can't read it all, you'll have my slides, but basically, I, along with Jeff Saber, Chair Acute, and Mark Chimowitz with Ralph Sacco for prevention, and Steve Kramer and Steve Wolf for recovery. And then there are representatives from the various RCCs who are very experienced clinical trialists in many cases. We also have a few cores that are important. We have the imaging core led by Max Wintermark. So when you're proposing a trial, he'll kind of look it over for kind of the logic check and for the reality, and give tips. And he's been working with a lot of trials. We have an educational card that I'll talk very briefly more about in a few minutes, led by Dawn Kleindorfer and co-chaired by Randy Marshall. And then we have these other committees you can see that sort of have jump in and out with proposals as needed. So ethics and competing trials, minority recruitment and retention, interventional and pediatric stroke have come up with special topics. And I should note, Heather back there leads the pediatric stroke committee actually. So, so she's a good person to know about for the pediatric stroke people. Trial concepts are just like in NeuroNEXT, they can come, and NETT, they can come from within or outside, and so they might grow out of a working group. For example, recovery is less well developed, and so they've been given the charge to try to build trial concept themselves. Acute, frankly, we get a ton of proposals. There's a lot of energy there, so we're more working with people who typically have built a concept and then bring it to us, and I like to think of it as we give some scientific input or advice, sort of like you have your faculty hours, to just get varying perspectives on things. And then we also look at trial feasibility. And I'll show you the trial development process. I won't go into too much depth, but you'll have my slides, like I said. This is kind of the big picture. The process is always evolving, just like Chris Coffey mentioned for NeuroNEXT. So right now, as of February, this is the way it works. And it's so you say you have a trial idea. Typically, you're contacting your NINDS program officer. Well, it used to be that your program officer actually worked with you a bit on developing the idea, making sure it kind of passes the sniff test, and then sends it over to us. Well, it started to be now that when you have a proposal, they'll basically say, is it StrokeNET appropriate? Which means, does it require 5 or more centers? And in that case, then they will immediately forward that concept proposal to either myself, Mark, or Steve, and we'll work with that protocol PI to help make sure that it fits with kind of the scientific concept proposals. We bring it to the working group when it's ready. We all give it advice. Our goal is to try to help make it better. And then, while that's happening, they develop a very preliminary budget with our StrokeNET staff, including Joe Broderick and Judy Spilker, and then they submit that concept proposal to NINDS formally with those budget numbers and having just kind of chatted with us about the science. So, and then you heard about this committee, the Extramural Science Committee, which is basically looking at programmatic priority, and whether that, these big trials are going to be upfront worthwhile to invest in if it gets a good score. So, and then it comes back to us, so you got approved and we're all happy, and then our clock really starts because we want to help you be able to get to that next grant submission, which is usually 2 to 3 months away, and we assess the feasibility of your proposal, how many sites we think would be needed from StrokeNET specifically to be able to get that trial done. You work in more detail with our staff on your budget, and then you submit for peer review. You get a great score, council says yes, and then you come back to us with a project, and you are the leader of that trial. It is your trial, and we provide that infrastructural support so that you're not starting from scratch with every single trial agreement and with all these RFPs. And we help fine-tune the protocols, since we've seen other protocols come through about what works and doesn't work. You get your CRIB approval, and then you go. So that's the process. Yuko Palish put together a very detailed and transparent flowchart that goes through 3 slides of the process. And I'm not going to walk through it in the interest of time, but I'm just going to have it there so you can see in the slides if any of you are thinking of approaching StrokeNET at some point. So just briefly, we are the newer StrokeNET, or the newer network in this group. We had 3 trials that were sort of already brewing when StrokeNET came into existence and kind of got folded into StrokeNET, but really largely had their own infrastructures, CROSS2, NIST-3, and IDEF. And then the 2 trials that are sort of homegrown within the network have been TeleRehab and Diffuse-3. I won't get into the details since we're running relatively late, but I can chat about those later if people are interested. I do want to mention though, so we just recently heard that Arcadia, a new trial, got a likely fundable score. We've got our fingers crossed it's going to council, we're hopeful. And proud to tell you all that it's actually somebody who was in the clinical trial methods course last year. So Kuman Kamel has done a really great job. Yeah. I'll let him know that he got applauded, so he's a really nice guy too. So there are actually 15 additional trials that have been submitted for peer review, and they're at various stages. Either they're being reviewed or they're being resubmitted. So that tells you about how much work's been going on behind the scenes. And then there are 13 more in development, which means that they've been referred to us and we're working on it, and maybe they're still cooking the designs or they're actually at the feasibility stages. So lastly, I just want to mention, because I think it's really relevant for all of you, whether you're in stroke and maybe not to some extent a little bit, is that there's this educational core that is led by Dawn Kleindorfer. And one of the things that their group does is supervise the RCC training programs. There are some very specific requirements because we actually have funding for trainees to be StrokeNET fellows, although frankly sometimes they're even junior faculty. They're people who've decided to transition to research and they can get $50,000 towards their salary for protected time. So it's just something to file away if you're stroke. And then they also have a formalized feedback process for research projects. So say you didn't get your fill of advice here, feel free, and you have a stroke project, feel free to come to StrokeNET. And there's a process where we have various stages of input depending on the level that you're looking for. And then finally, there is a didactic and professional development webinar series. And so I just flashed these up. These are the talks that were didactic and kind of more clinical content specific and trial specific. And then you see there's some overlap here with topics you've heard of this course in the professional development webinars. These are all available on the StrokeNET website if you just stick into Google NIH StrokeNET, if you just want another perspective on creating a study budget, for example. And these are all, you're welcome to attend these if you want to hear what the schedule is for next year. We can forward that along. So like I said, the process is always evolving, so feel free to reach out to me if you ever have any quick questions about how to kind of make StrokeNET fit in with your proposal. Thanks. Any questions about StrokeNET?
Great, thank you. So the remainder of the time was